Hi dear students, welcome back to our channel N Kumar Basics of Physics. Dear students, in this video we are going to discuss about the third quantum number, that is the magnetic quantum number. Dear students, I already uploaded about the videos regarding the principal quantum number and angular quantum number. I will provide the links of those videos in this description. You must watch. After completion of principal quantum number video and orbital angular quantum number video, then only come to this video. Okay children, without late I am going to the topic. What is mean by magnetic number and what is its importance? Magnetic quantum number, it can explain about the orientation of orbitals in the space surrounding of the nucleus, and that should be explains the number of orbitals in a subshell. Number of orbitals in a subshell. That is simply about the magnetic quantum number. So dear students, magnetic quantum number is introduced by the Landé, and magnetic quantum number can be represented by the letter ML, M suffix L. Got it children? ML. And magnetic quantum number values are starts from minus L, 0, plus L plus L. For example children, if L value is 0, ML also 0. If L is equals to 1, then ML values are minus 1, 0, plus 1. And when L is equals to 2, minus 2, minus 1, 0, plus 1, plus 2, like that. So if L is equals to 3, minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3, like that. So here, look here, for a given value of L, ML values are minus L, 0, plus L. Clear children? So in this way we can write the ML values for the L values. Clear children? So this is the point you have to remember. It indicates the orientation of orbitals in space and number of orbitals in a subshell children. Got it? Now we have to check how many orbitals in a subshell by using this relation children. Look at the table from here. L value, ML value and number of orbitals in subshell. So what we know children, when L is equals to 0, that is what which subshell S. When L is equals to 1, P. When L is equals to 2, D shell. When L is equals to 3, F shell. So when L is equals to 0, ML value is 0. ML value is 0. Then obviously what, right? Number of orbitals in subshell. Formula is what? 2L plus 1. 2 into 0 plus 1, that is equals to 1. Clear? And similarly here, in L is equals to 1. L is equals to 1. Here we will write ML values are minus 1, 0, plus 1. Clear? Minus 1, 0, plus 1. And obviously here 2 into 2L plus 1. 2 into 1 plus 1, that is what? 3 orbitals are there. And L is equals to 2. L is equals to 2. Then ML values are minus 2, minus 1, 0, plus 1, plus 2. Then how many orbitals are there? 5. 2 into 2 plus 1, that is what? 5. Clear? And L is equals to 3. F subshell and values are, ML values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Clear? Again what is 2 into 3 plus 1, that is what? 7 orbitals. 7 orbitals. So children, you have to remember, in S subshell how many orbitals are there? 1. In P subshell how many there? 3. In D subshell how many orbitals are there? 5. In F shell how many there? 7. So these are the number of orbitals in S, P, D, F subshells. So children, if you want to find out the number of electrons in the subshell, simply we have to write formula like this: 2 into 2L plus 1. 2 into 2L plus 1, That is what? Number of electrons in the subshells. This column is what? Number of electrons in the subshells. Simply what, right? 2 into L plus 1. Already 2 L plus 1 value, this is there. That's what, right? 2 into 1, 2. Again 2 into 3, 6. 2 into 5, 10. And 2 into 7, 14. So in S subshell, how many electrons are there? 2. And P, 6. And D, 10 electrons. And F, 14. So 1 orbital, 2 electrons. 3 orbitals, 6 electrons. 5 orbitals, 10 electrons. D, 7 orbitals, 14 electrons. That's why the maximum capacity of one orbital is how many electrons? 2 electrons only. 2 electrons in a orbital. Clear, children? Shell, subshells, and number of orbitals in the subshells. How we can represent them in a single table? We have to represent the main shell, subshell, and number of orbitals in their subshells. How we can represent them? That should be given one table. Look at that. The same table was given in our textbook. Watch very carefully. Shells, subshells, and the number of subshells. Number of orbitals in the subshells. Number of orbitals in subshells. Look here. When n value is 1, what it is? L value is 0. Before going to explain this, you have to observe the headings of the columns. N, L, ML, subshell notation, and number of orbitals in the subshell. So children, when n is equals to 1, L value is 0. When L value is 0, ML also 0. That's why here subshell notation is what? Principal quantum number is 1 and L is 0. L is 0 means what? S orbital. That's why we have to write this is 1s. And number of orbitals in the subshell, what it is? ML value is 0. 0 also it is countable. That's why it is 1. Clear, children? And next thing, when n value is equals to 2, we have L values are 0, 1. L values are 0, 1. When n is equals to, L values are 0 and 1. When L value is 0, ML is 0. Clear? Then subshell notation is what? It is 2s, and 0 means what? S. That is what? 2s. Clear? When n is equals to 2, L value is 0 and ML value is 0. Now subshell notation, how we can write? It is the main shell 2 and L value is 0. L value is 0 means what? S orbital. That's what, right? This is 2s. And this is ML is what? 0. 0 also countable. That's why the number of subshells are 1. Clear? So this is for L is equals to 0 value. And now for L is equals to 1. For L is equals to 1. What you can write? ML values minus 1, 0, plus 1. Clear, children? Now here L value is 1. L value is 1. L value is 1 means what? That is the p orbital. That is what? P orbital. And that is in the main shell of 2. That's why we can write this is 2p. Clear, children? Got it? Subshell notation, how we are writing? Subshell notation is nothing but here L value is 1. L value 1 means that represents the P subshell, and that P subshell in the main shell of 2. That's what we write. This is 2p. And number of orbitals in the subshell. In that subshell, how many orbitals are there? So already we discussed now. ML values represents the number of orbitals. That's why this is a 1, 2, 3. That's why number of orbitals are what? 3. So this is about this simply here. For L is equals to 0 and for L is equals to 1 children. So this is completely related to the as n is equals to 2. In the same manner, my dear students, here n is equals to 3. What it means? L, how many L values are we have to write? As we have to write 0, 1, 2, 0, 1, 2. Clear? When L is 0, what you have to write, children? When L is equals to 0, ML value is 0. ML value is 0. When ML value is 0, what you have to write, children? L is equals to 0 means S. This is the S orbital, and that should be in the third cell. That's what this is 3s, and number of orbitals are what? S0. That is the 1 here, children. And next thing is here in the same manner, here we can go for L is equals to 1, n is equals to 3. In that we have 0, 1, 2 are the L values. Now we can go for S. L is equals to 1. L is equals to 1 means what? That is the p orbital. When L is equals to 1, we have to write ML values are -1, 0, plus 1. 0 plus 1. Then obviously what you have to write, children? So here -1, 0, plus 1, these are ML values, and 1 is the L value. When 1 is the L value, what you have to write? This is the p orbital, and in that it is third shell. That's why what you write? 3p. What it is? 3p. And number of orbitals how many? -1, 0, plus 1. How many there? 3. Clear? When n is equals to here 3, and L value is what? 2. When L value is 2, we can write values are -2, -1, 0, plus 1, plus 2. Clear? Here L is equals to 2. L is equals to 2. So this is L is equals to 0, L is equals to 1, and this L is equals to 2. When L is equals to means obviously that is what you have to write, that is d orbital. What it is? D orbital, children. So that's why here simply what you have to say, now it is D, and where it is? In the third main shell. That's what I write, 3D. Clear? And now what it is? Number of orbitals in the subshell. Number of orbitals in the subshells. So children, here you have to count the ML values that will use the number of orbitals. 1, 2, 3, 4, 5. -2 is the 1, -1 is the 2, 0 is 3, plus 1 is 4, plus 2 is 5. That's why here what you have to write? S. That consists of 5 orbitals. When L is equals to 2, in that D is there. In that D shell how many orbitals are there? 5. In 3p also it is 3. 3s is 1. In 3s subshell we have 1 orbital. In 3p 3 orbitals. 3d 5 orbitals. Clear? And now here for fourth one, when n is equals to 4, same process. When n is equals to 4, L values are 0, 1, 2, 3. So 0, 1, 2 remaining all are same. We have to follow the same thing. When L is equals to 0, ML also 0, ML also 0. So when it is 0, obviously L0 means what? S orbital, and initial it is there, fourth one it is there. That's what, right? 4s. So here S, this is the 1, and similarly here now we can go for what it is? L is equals to 1. So ML values are -1, 0, plus 1. L is equals to 1, that is P. In the shell of 4p, it is now what you have to write? 3. -1, 0, plus 1. 3 orbitals are there. And similarly we can go for now L is equals to 2. So L is equals to means ML values are what? -2, -1, 0, plus 1, plus 2. Then what you have, children? It is what? 2 means what? D. That's why what you write? 4D. L is equals to means D, and it is in the shell of 4D. So in that how many orbitals are there? So 1, 2, 3, 4, 5. So like that. And next, children, n is equals to 4, and L is 3. When L is 3, what you have to write? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3 children. Total how many there here? Yes. L is equals to 3. L is equals to 3 means what? That is the F orbital. That should be in the shell of 4F children. And here 1, 2, 3, 4, 5, 6, 7 ml values are there. That's why 7 orbitals are there, children. 7 orbitals are there. So in this way, children, we can explain the main shell, subshell and orbital values according to the magnetic quantum number. So children, I hope you understand this one. If you can understand this one, like, share, comment the video. Thank you for watching. Bye. Take care.